In this Unity tutorial, we're going to learn how to make this first-person character controller that can interact with physics-based things like this cube here and this little trampoline. It can go up and down stairs, and it's also very smooth on ramps. First step is to make the project. Just hit New Project and name it something like Rigidbody Controller. Select the 3D template and just hit Create. In this tutorial, we're going to use the new Unity input system. To enable it, go to Window, Package Manager, change this drop down to Unity Registry, and just search for the input system. Select it and just hit Install. Here it's going to ask us if we want to enable the backends, and doing so will restart the editor. Just go ahead and click on Yes. Once the editor is restarted, just close the package manager. I'm going to create a 3D plane in my scene and just reset its position. I can also change the scale to something like 2 on each axis, and I'll just quickly put a material on it. Now that I have my ground here, I'll just rename this plane to ground. And now we need to make our actual player here. So what we're going to do is we're going to create a 3D capsule, and we can just rename it to player. We're going to add a rigid body to it. You can leave its settings here for now. Create a empty game object as a child of the player. Name it to something like camera holder. Drag your main camera under the camera holder and reset its position. Change the field of view to something more like 90. Now if we select our player here, we can see that it's currently under the ground, so let's just reset its position. Put it to something like 0 on the X, 1 on the Y, and 0 on the Z. So here's our player. We're going to want to move our camera holder up on our player to make it somewhere where the head would be. So let's put it up to something like 0.5 on the y-axis. That looks a lot better. We'll add a new component to our player here, and we'll just call it our player controller. Hit create and add, and then just double click this to open it up in Visual Studio. First thing we're going to do is we're going to make sure that we're using the Unity Engine .input system. You can see here that that gives us an error. We can fix this by going back into Unity here. Go to Edit, Preferences, External Tools, and then just regenerate the project files. If we just reopen our script here now, we're just going to reload all, and you can see now our error is gone. So let's make a reference to our rigid body. Let's make a reference to our camera holder. We'll make 2 floats, one for our speed and one for our sensitivity. We'll make 2 vectors, one for our movement and one for our looking. A private float to keep track of our current look rotation. And that's all for now. We're going to make a couple of methods here to gather our input. We can make a void called onMove here, and it's going to take in an input action dot callback context, and we'll just call it context here. open and close some curly brackets. And in here, we'll set our move vector 2 equal to context, and then we'll just read the value as a vector 2. We can just copy this down one more time and switch it to our on look and switch this here to look. That's it for our input. We can just minimize here. Down in the fixed update, we can do our movement. So for our movement, first thing we're going to do here is we're going to find our target velocity. We're going to get our current velocity, and we'll just make a new vector 3 here called current velocity. We'll just set it to our rigid body's velocity. We'll make a new vector 3 for our target velocity. And we'll just set that equal to a new vector 3. And then we'll just use our movement on the X and 0 on the Y, and our movement on the Y. So this is going to take our input here and it's going to turn it into a vector to help us move our character. We're then going to multiply our target velocity by our speed, float here, and then we're going to align our direction with our player so that we always move in the correct direction. We'll just set our target velocity equal to transform direction of our target velocity. Then we can just calculate the amount of forces we want to put onto our player. We'll make a new vector 3 called velocity change. And we'll set this to the difference between our target velocity and our current velocity. Now we might want to limit the amount of force on our player for safety. So we can just say vector 3 dot clamp magnitude. We're going to clamp our velocity change, and we're going to clamp its magnitude to max force, which we need to create up here. We can make a new float for our max force, and then we can simply just add our force to our rigid body. So rigid body dot add force, add our velocity change, and set it to force mode dot velocity change, and this will add a instant velocity change to our player. Save this and go back to Unity. Then we can assign our rigid body and our camera holder. Set the sensitivity to something like 0.1. Max force you can set to something like 1. For our speed we can do something like 4. And this won't work right now because we need to add a player input component to our player, and it takes in an input actions asset. We'll just hit create actions here, and we'll name this something like controls. In here we can edit our keybinds. You can see by default it gave us a move and a look keybind, as well as a fire, but we won't need that for this tutorial. We're going to switch the behavior to invoke Unity events, In the player, we can add a slot for the move and look, drag our player controller script into both of them, and just set our on move method here. So now if we hit play in the editor, you can see that we can move around, but currently our player has fallen over because we forgot to constrain our rotation on all the axes here. So now you can see that we can move our player around in the scene using the W, A, S, and D keys, as well as a controller if you have one set up. Now we want to add some rotation to be able to look around. To do that, let's first clean this up a bit. We'll just make a move method here. And we'll put all of this current code into the move method. And let's just call move from our fixed updates. So move. We can now minimize our move method. For looking, it's best to do this in the late update method. This is because we want to move our camera after the rest of the scene has been updated. So in the late update here, we're going to turn our player just on one axis. We can get our transform and we will rotate it on the up axis, so vector3 dot up, and we'll multiply that by look dot x, which is the x-axis of our mouse, and then we'll just multiply that by our sensitivity. Now we can make our player look up and down. To do that, we can add to our look rotation float, and we can just add in our negative look.y. This is just going to flip the mouse input for us because by default it's inverted. We can multiply this by our sensitivity again, and then we can just rotate our camera holder. So we can just say cam holder dot transform dot Euler angles, and we'll set it equal to a new vector3. For the x we're gonna put in our look rotation, and then we're going to put in just our current y rotation and our current z rotation. So now you can see that if we go back to Unity and we assign our on look here in our player input, we can now look around in our scene with the mouse, and we are always walking in the direction that we're looking. But currently we can look down past straight down and past straight up, and we usually want to limit this in our game. So we can do that easily by just clamping our look rotation. We'll just set look rotation equal to math dot clamp, and we'll clamp our look rotation between -90 degrees and 90 degrees. So now you can see if we run this, it won't let us look up past 90 degrees, and it won't let us look down past 90 degrees. Now our mouse in the middle of the screen here is pretty annoying, so back in our code we can just hide that, in the start method by just writing this little piece of code, just locking our mouse. And that will automatically hide and lock our mouse to the center of the screen, so we can always keep rotating and our mouse doesn't hit the side of the screen. And this is pretty good right now. Let's just add in some objects to our scene to interact with. I'll just make a couple of things really quick. So I've gone ahead and added in some things to our scene. I've added in this ramp here, this cube with a rigid body that should fall, this staircase here, and this little trampoline using a configurable joint. So now if we hit play here, we can see that we can go up and down this ramp. But currently some weird things are happening. First of all, we're not falling back down to the ground. We can fix this by going back into our script. And in our movement here, we're going to want to set our velocity change after we calculate it to itself, but on the y-axis we're going to set it to 0 so we don't try to add any force there. You can see here that that line of code fixes the falling, so now we fall back down to the ground normally. We can go up these stairs here pretty smoothly, but currently we can't jump. So to add in jumping, go to your controls and add a new keybind for jump. I'm just going to set mine to the space bar on our keyboard and just set it to the keyboard control scheme. Save the asset here, and let's go back to our script. We can move all of this look code into a new method called look, so void look. And then in our late update we can just call look. So now for jumping we can also call in our fixed update jump. And of course we need to create this method, so void jump. We'll need to make a new method here to get the input. So we'll just copy, let's say, our onLook method here and rename it to onJump. And in here we'll just call our jump method here instead of the fixed update. So now whenever we press the jump key, it's going to call our jump method here. We'll make a new vector3 called jump forces and we'll set it to nothing, so vector3.0. We're going to check if we are currently on the ground, so if grounded. But currently this doesn't exist yet, so we'll just make a boolean in here. So public bool rounded. And if we are grounded, we'll set our jump force to be up, and we'll multiply it by this jump force variable here that we can create. And then we'll simply just add that force to our rigid body, like that. And now this grounded bool is always going to be false unless we change it somehow. So the way we're going to change it is we're going to make a public method called setGrounded. This is going to need a bool for the state. So the current grounded state, and we're just going to set grounded equal to that state. And that will be it for our player controller script. We're going to select our player, and we're going to add a empty game object to him, and let's just call it ground check. We're going to add a box collider to him, mark it as a trigger, and we can move it on the Y to something like -1. We then shrink this size down to something like 0.1 and 0.4 or 0.9 and 0.9. So now we have this little box collider here. We're going to add a component to it, and let's just call it ground check. And we'll double click on it to open it up in Visual Studio. And in this ground check script, Unity has some really useful methods. One called on trigger enter, and it gives us the collider that we entered, and we need to make a reference to our player here. We're going to add some code into this method, and basically what this does is if the object we collided with is ourselves, then we just return and do nothing. And if it wasn't ourselves, then we will reach this code here, which will get our player controller and set grounded to true. We can copy this code down 2 more times. We can set this one to on trigger exit and set grounded to false. And then on this last one here, we'll say on trigger stay and make the grounded true. So what these 3 things here do is when we hit the ground, we set grounded to true. When we leave the ground, we set grounded to false. And while we're on the ground, we're going to keep grounded true. So now back in Unity, assign our player here and assign our jump force. I found that 3 works really well, and we're almost done with our player controller now. You can see that we can move around, but we need to remember to trigger our on jump method here. It looks like I misspelled that. There we go. Now that that's assigned properly, you can see that now we can move around in our scene. We can jump with the space bar. Our trampoline here works. And we actually have weight on our player, and you can see it does work. We can interact with this physics cube, and the only problem with our player controller right now is that if we are up next to something and we jump, we rub up against it, making it really hard for our player to jump. So if I'm flying and I walk into the side of our ramp here, then I kind of stick to it, and it's the same thing with our cube here. So if I'm pushing it, then I might roll up onto the cube because there's so much friction. So we can fix that by creating a physics material, and I'll just call it player. And I'll drag that onto my player's collider. We'll set the friction and bounce combine to minimum, and just set all these values to 0. So now our player pushes cubes easily, and we can't get stuck on the side of walls anymore. And everything works really smoothly.